chat. Hello and welcome back to Just Code It. Today we're going to take a look at how we can parallel process with multiple agents going out and doing separate tasks and then coming back together at the end and forming a final response. I have a few notes up here if you want to take a look at them. This parallel processing can be used in two different ways. It can be used for voting or soliciting, either doing the same task but more of it, or doing different tasks. Those are the two main ways that they're used. The key concepts of the graph we're going to create today, or the workflow, is we're going to have a starter agent and it's going to split the task into three different groups. One agent is going to create jokes, one agent's going to create questions, and one agent's going to create related topics. You can see how this structure can lend itself to deep research agents, sending them out to grab information, and then you could have another agent back here doing related topics to keep generating search terms. Not only are you able to get speed increases by doing this parallelization, you are also able to really tailor your LLM. You can tinker them and actually do hyperparameters for each one that's specific, and also specific models that are better in specific areas. We're going to do that with GPTO, going to be the one that's going to be relevant questions. Mini is going to be creating the jokes, and then 3.5 is going to be doing related topics. But let's just get started and jump right into this. Like always, we're going to do our imports, load our environment variables. If you want to use LangChain tracing and use Langsmith to see the path that it's going, you can set that up like this. I haven't set it up yet. I did not do that. After that, we're going to create our state, where we're going to do the agent state is going to be a typed dict, topic, question, joke, related topics. Run it. After setting up the LLMs, we're going to create a method called create generation chain. We're going to use a chain and swap out the prompt template for our chain for each different one of these, the LLM and the prompt template for each one for this chain for each one of our agents. So this kind of just makes it so we're not repeating code. After creating that method, we're going to jump right into using it, using the create generation chain. And what we're going to do is pass it each one of those LLMs we created for the question, joke, and related. And then we're going to construct a prompt, passing in our topic in the prompt, and then giving it some information about how we want the output is going to be in JSON, and then generate 5 questions, generate 3 jokes, generate 4 topics. After creating those chains, we're going to come down and start creating our nodes. Each one of these methods or each one of these nodes is essentially going to have the same process. If you're doing different things with them, we just have kind of the same method that's going on. What you could even do in one of these is these could be subchains or subgraphs within here, but we're just going to do some very basic stuff where we're just going to use the chain, invoke off of it, pass it the topic. That's going to return the results. Then we're going to grab that result, grab the output. That's going to be for the question, because in our state graph, we have questions, jokes, and related topics. We got to match them up. We do that for each one of these. We grab the result output and we match it up. Now, when this runs, we'll have our completed graph or our completed state. Now we're going to build the graph, workflow. We're going to add the question node, joke, related topic nodes. After creating the nodes, we actually are seeing something a bit different now, where we're going to have 3 entry points. Normally, what we've been using is a single node entry point that then splits the query up. But you can also just do 3 entry points and pass straight in the query. It's nice to be able to process the query a little bit before handing it off to the LLM. These are just going to get the straight query from the user into those methods up there. After creating those nodes, we're going to draw those edges to the end and finally compile. It's a pretty simple graph. Now we can just look at it. And we already got it displayed over there. Let's get rid of that now. Okay, finally, we're going to test a single topic. The test topic is going to be artificial intelligence. I just did a little for loop here, and we're going to first grab the initial state or construct that initial state with the topic. That's the initial state. Everything should be empty except the topic. Then we're going to pass that initial state into the app and then invoke it, which gives us our final state. Then that final state, we're going to grab the topic and then uppercase it. After the final state returns, we're then going to enumerate over the questions, the jokes, and the related topics and just print them to the screen. Then we have some like formatting in there, but here we are. You can see how fast it ran. If that was running in sequence, it would not run nearly as fast as that, but it's already done. And it generated quite a lot of data and tokens right there. You can definitely see the performance benefits that you can get from using this. With this method, I just added a bunch of formatting. It's essentially the same thing as the previous one. It's just formatted with all this rich stuff to make it look prettier on screen. At the top, we're just printing our settings. And then down here, we're going to do generate joke, showing when it's actually processing, get our results. That was that print statement up there, uppercased it. Artificial intelligence, then our questions, our jokes, related topics are all printed to the screen. If you're using a llama, you probably will not see these kind of performance. Like you won't see a 3x improvement because you're just running it on your own hardware. This is not super useful if you use a llama a lot, but if you're using APIs, it will definitely increase the throughput of your application. And that is it for parallel agents. I hope you enjoyed today's video, and I'll see you next time.